Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in the previous lecture we started our discussion on the new package, that is Pandas. So, we will we'll do a slight recap of what we discussed briefly in the previous lecture, and then we will pick up from there. So, as we have discussed in the previous lecture as well, that NumPy package is mainly for generic numerical processing. However, if we want to work with tabular kind of data, structured kind of data that we typically do in the analytics area, then Pandas package actually provides all those facility. However, Pandas is based on NumPy and various other packages also. So, that is why we have covered them before, so that the foundation is there when we discuss the Pandas package. And many things that we would be learning in this package, they would be directly relevant for the analytics, the data processing part, the data transformation part, the summary statistics that we typically generate. So, all those things we would be using a lot more of Pandas functionality to directly perform some of these analytics related tasks. So, let us start. So, as we discussed Pandas package, this is typically used to work with heterogeneous data, that is tabular data. That means all the columns, they would be representing different variables, and therefore, they could be different data types as well. One could be continuous, another could be categorical. So, that kind of differences. So, in terms of Python context, one would be floating or integer, one would be having floating or integer data point, another would be having a string or or boolean kind of data type. So, that is going to be one difference. So, that is what Pandas provide us. Facilitates faster and easier data processing. So, because many functionality they are for they have been developed to work with heterogeneous data. So, therefore, directly they are going to be relevant for data processing, and these functionalities make this processing easier and faster. So, as we discussed this we first typically import the libraries, import pandas as PD. So, this is first thing that we do. So, let me perform this. So, before I do this, like we have in a previous few lectures we have started doing this aspects also. We have started clearing the output. So, let me clear all the previous output, and now let us start. So, first importing of this package. Now, then certain libraries we would be using quite often. So, we would like to import these libraries, series and DataFrame. These are the two data structure that we would be discussing in this lecture. So, let me run this. Now, the series and DataFrame, these are the two structures. So, let us start with the series. So, as we discussed, series is a sequence of values similar to what we have done in 1D array along with an explicit custom index to access the values. So, we will have the index here, which would be explicit, it will not be. So, whenever we create a series object, and whenever we are trying to print it, we would see an explicit index in contrast to what we have in array, where we just see the sequence of values. Here in series we see the sequence of values and also an explicit index. Now, I have also mentioned custom index, because we can always manipulate this index as per our requirement, because as you would understand that in tabular data, structured data set that we typically use in analytics, there the indexing we sometimes we would like to change, because these are nothing but labels. So, they could be represented using numeric codes or string values. So, therefore, sometimes we would like to modify these index, the explicit index that we have in series and DataFrame. So, that is why I have mentioned that explicit custom index to access the values. Now, another way to understand a series is that it can be considered like a fixed length dict, where you can understand in dict whatever we have discussed in the previous lectures, that key value pair that we have in dict. So, as elements of dict. So, here also a kind of mapping is happening. The mapping is between index values to data values. So, that kind of a mapping is being done in series. So, in a way we can consider series as a dict kind of object, dict like object. Now next the construction part. So how do we create a series object? So typically created using a series function. So one code example we have given here, series 1, and this is the function, series function pd dot series, and within the parentheses you can see here that we are passing a list of 4 values here. In this first example we have not specified any index. So we have a default index in this which is 0 to n minus 1, where n is the total number of elements that are going to be present in the series. So that is going to be the default index. So in this case if I run this, we will have created a series object, series 1. So if I run this again, you can see here in the output series 1 with 4 values and indexing again just like in other data structure. Indexing starts with 0. So this is also 0 indexed. So the index, as you can see, is displayed explicitly here. The first column is actually the index 0 1 2 3, and then we have the values for of the series, that is 4 values 22 33 44 and 55, and then the data type of these values, integer 64 bit. So this is the series object. This is the simpler way of constructing or creating a series object here. So let us move forward. So next thing is series properties or attributes. So let us first talk about the values attribute. So this values attribute is like an array object. So if I run series 1 dot values, the only the one column of values that we had in series 1 that is going to be printed here, produced as output here. So series 1 dot output, you can see in the output it is clearly mentioning array and the values there. So you can see the column that we have, it is actually, so you can see how the data structures of Pandas package, series and data frame, they are actually based on arrays, and arrays they are actually we have discussed in the NumPy package. So this is the certain similarities and foundation that you should be able to notice here. Now next attribute is index. So index we have talked about, however we have an attribute and we can access using that. So series 1 dot index. So this is quite similar to when we call this function range n. So the output is quite similar to that. So this index is based on or similar to the functionality of this function. So if I run series 1 dot index, you can see in the output we have range index, start point, stop point, and the step over there. So this is how the values part and the index part can be accessed using these attributes. Now let us move forward. Now as we said that the index, the explicit index that we have for series object, this can be customized. So we can customize this as a list of labels. So let's look at this example, series 2, and on the right hand side we have pd dot series, and within the parentheses we are passing the list of values, sequence of values, and then index we have mentioned 4 labels here, a b c d. You can see 4 values and correspondingly 4 indices we have mentioned here. So if I run this, I would have created a customized index here, and you can see the first column is referring to the index, the custom index that we have just created, starting from A, then B, then C, and D, and then we have the one column of values 22, 33, 44, 55. Let us move forward. So we can also check the presence or absence of labels in a series. So like we discussed that the series can be considered as a dict kind of object. So here also key value kind of thing, those kind of presence and absence we can find out here. So let us see whether this index C is present in series 2. So if I run this line number 9, and you can see it is present, as you can see in the output number 8. So therefore in the output 9 it comes out to be true. Similarly another example, let us see this label E, whether it is present in series 2 or not. So as you can see in the output 8 it is not present. So therefore we should be expecting false as the output. So that is the output that we have got. Similarly, let us also retrieve these values, values and index attribute for this series 2. So, series 2 dot values. So, you can see this array with 4 values and index, you can see A, B, C, D. So, this is how we can create conduct index and do few things, check presence and absence of labels and access the attributes also, just like the regular series object. So, accessing values using labeled indices. So, how we can do that. So, for this again the brackets operator we can use. So, in this case series 2 within the brackets we can specify the label here. So, for an example A, so series 2 within brackets A. So, in this fashion we would be able to access the value corresponding to this index A, this index label A. So, that comes out to be 22. Similarly, if we want to check if we want to access value for multiple indices, so that can also be done. So, within series 2 and within brackets we will have to specify a list of labels. So, in that list of label in this next line of code I have indicated the 2 labels A and C. So, let me run this and you can see output number 14 we have 2 labels A and C and corresponding values as well. However, the order is not really important here when we are accessing values in this fashion. So, if I run something like this series 2 and within brackets I am specifying a list of these labels. So, if I run this and you can see that whatever order we had indicated in the brackets operator, the output is also according to that order. So, in any order, so order in that sense is not important, that like order is fixed, rather whatever we are indicating as per that the output is going to be retrieved. So, let us move forward. Now, here because in this data structure that we just talked about series, the link between in the index and value, that is very important, and it is supposed to be a stable link, it is supposed to be a robust link. So, whenever we are operating on the values of the series object, any operation that we are performing, so this link should not be disturbed. So, that is the case here also. So, index value link is not disturbed by execution of various operations. So, another aspect is that automatic alignment of index label with corresponding values and results just like in R platform. So, in previous courses that I have taken in the NPTEL for the NPTEL platform, business analytics and data mining modeling, there in the R platform also you would always see whenever we are applying any operation, the index, this link between index and columns and values, that is very consistent. The same thing is here. So, automatic alignment is inbuilt in this functionality. So, we will take example, we will do a filtering example here. So, we will take this series 2 object and within the brackets we have put this conditional statement series 2 greater than 0. So, all the values which are greater than 0, they are to be so this will return a boolean output, and only those indices which comes out to be true, only those are to be displayed. So, if I run this, you can see since all the values are greater than 0, therefore, we have got this kind of output consisting of all the values of this series object. So, let us move forward. Scalar multiplication. So, we can multiply this series with some scalar value like 9, and in the output you would see that all the elements of the series object they have been multiplied. So, in a sense broadcasting has happened over the rows. So, for all the rows this scalar value has been multiplied and broadcasting has been done. So, broadcasting is also an important concept in the Python platform. So, through a few examples we would be covering this, however, we will not be going into more details of that aspect. Now, let us take another example, let us take this math operations. We will import numpy here also. So, we will take exponential of this series 2. So, np.exp is the function that we are calling, and we are passing on this data structure series to this object here. So let us see how this function is going to work, because now numpy, all numpy functions are going to work here, because essentially as we have discussed that these two data structures, series and data frame, they are based on arrays. So let me run this. So you can see in the output all the series values and exponential have been taken, and that output has been displayed here in the output number 18. Now let us take another example. So in this case we will take another type of data structure and convert, you take that data and convert it into a series kind of object. So we will convert Python dict object into a series object, because as we discussed that we said that series can also be considered like a dict kind of some behavior is like that kind of thing, because mapping between index and values is also there in series, just like in the dict object where we have the mapping between keys and value pairs. So in this case you can see we have taken this example pin code and a few towns or cities in the Uttarakhand state of India, they have been given as an example here. So pin codes we have for these towns, Roorkee and 247667, Dehradun, Haridwar and Nainital. So if I run this, we will have this dict, and we can pass on this dict object to our pd.series function, and this function will handle take this data and convert it into a series object. So if I run the next line and let me run and access the value. So you can see that the key part of the dict object that we had, that has been taken as the index in the series object. So in the pin code dict object that we had city names, town names, Roorkee, Dehradun, Haridwar, Nainital, those have been taken as indices in the series object, and the pin codes that we had in the dict object, the value part of the dict object we had the pin codes, they have been taken as the value part in the series object. So you can see how this translation is happening here. So we can easily convert dict object into a series kind of thing. Now if we want to access the index part that we have just created for series 3 object, so let me run this line of code. You can see index with 4 towns, names of 4 towns here, and in this fashion we can produce this output. So now sometimes we might be required to change the index also, we might like to add few more rows or something in our data. So for that we will have to modify the index also. So that can be done using the index argument in the series function. So let us take this example cities, this is a list of these town names. So in the cities we have added few we have added one more, Dehradun, Haridwar, Nainital, Roorkee and Tehri Garhwal. So here you would see we have changed the order also here. So in the next line of code, so let me first create this object cities, this list object, and now we are passing on this list object cities into the second argument in the series function. So first one is pin code, the dict object that we had created. So and the next one is the index. So now this, because we are clearly specifying, we are using this keyword argument here and clearly specifying our index here. So this index would be taken while constructing the series object number 4, series 4. So data value part would be taken from pin code, and then the index part would be taken from this index argument, the cities, and this series 4 object is going to be constructed. So let me run this, and you can see in the output that first is as per the order as specified in the cities index, Dehradun, Haridwar, Nainital and Roorkee. So order is as per that, and then Tehri Garhwal, but we did not have the pin code value for Tehri Garhwal in the dict object pin code. So therefore that is missing, and the missing values in this package Python and in the Python platform and in this package as well, they are specified as NaN. So you can see the same has happened. So while we are changing index, if there are any unmatched indices, so for them those indices are going to be created. So, a sort of union is going to be performed. So, here you would see as per the pin code, the dict object, we have a number of indices, and as per the index argument, index keyword argument, we had specified cities. So, while we are taking values from there and indices from here, the matching will happen, and for the matched values we have the indices, correct alignment, automatic alignment, indices and values. Wherever we do not have, we have one thing missing, a new row is going to be created, and if the value is not there, then NaN is going to be displayed. So, that kind of output has been produced here. Now, if you want to detect missing data in these objects, so for that we have these function is null and not null function. So, we can use them. So, for example, series 4 object, we can call this pd dot is null, this function, and we can within the parenthesis we can pass on this series 4 object here. So, if I run this, and you can see in the output number 25 which data is missing. So, in this case you can see is null. So, you can see Tehri Garhwal, for that value part is missing, so that comes out to be true, others are false. So, you can see also data type D type is also indicated as bool. Similarly, not null. So, this is another function to perform the similar kind of processing. So, here you can see that only first 4 values Dehradun, Haridwar, Nainital, Roorkee, for them it comes out to be true. The last one it false because it is actually null. So, we can in this fashion we can detect any missing data in our series object. Now, this was these were the is null and not null, these were the these are the functions that we had used. We also have the corresponding methods, so is null and not null, we have these corresponding methods. So, we can also call them. So, series 4 dot is null. So, in this fashion we can call these methods. So, let me run this and you can see the output. Similarly, series 4 dot not null method also we can call this one also. So, in this fashion we would be able to produce this output. Now, let us look at the alignment feature. So, once again, so series 3 plus series 4, if we make this if we perform this addition operation here between these two series objects. So, let me run this, and you can see that the values in the output 29. So, the pin codes though pin code is a categorical variable here, we are still into our Python part. So, these are numeric values, so they have been added up. So, you can see Dehradun, the pin code series 3 and series 4 both had same values added up, Haridwar, Nainital, Roorkee added up, only Tehri Garhwal where we did not have value and it is NaN, and you can see everything is aligned. So, whenever we are performing these kind of mathematical arithmetic operations, you can see the alignment between index and values is maintained, and accordingly the operation is applied. So, for the matched indices the operation will work, for the unmatched of course NaN is going to be there. Now, let us move forward. Now, we have another aspect, another attribute here, name attribute we have for series object. So, series 4 dot name. So, in this case we can specify the name attribute for this series object as pin code. We have the name attribute for the index also. So, for the series object as well as its index. So, we can use series 4 dot name to specify the name attribute of the series object, and we can type code series 4 dot index dot name to specify the name of the index. So, in this case it is about series is about pin code values, pin code numbers. So, if I run this, name would be defined, and similarly for index those are actually city city names. So, now let us have a look at the series 4 object. So, you can see that city is appended like a header there on top of the list of towns. In the first column that we have city, you can clearly see, and for the name of the series you can see last line, last row in the output, name pin underscore code. So, for this series object this name is also indicated there. Let us move forward. Next aspect about this is changing index. So, we also have index attribute. So, we can use that also to change index. So, let us have a look at the index values here. This is our series, and in this, if you look at the first column, which is the which are the index values 0, 1, 2, 3. So, for some people they might not prefer the 0 indexed thing. So, for that they can customize their index and they can make it like 1, 2, 3, 4. So, in the next line of code we are doing exactly that, series 1 dot index, and we are passing this list sequence of values 1, 2, 3, 4. So, if I run this, I would be able to change the index. So, earlier when we change the index, we used the index argument in the series function. Now, this time when we are changing index, we are using the index attribute to assign it a new index. So, these are two different ways to perform the same thing. So, now let us have a look at the output. So, you can see output number 35, that series 1 and the first column index has been changed. 22, 33, 44, 55, and the corresponding indices are 1, 2, 3, 4. So, that was the main points about those were the main points about the series data structure, series object. Now, let us move forward to another very important data structure, that is data frame. So, in our previous courses we as we have seen that we have been typically importing the Excel data sets into a data frame kind of a variable in R platform. Similarly, here in the Python platform we have data frame object, and this is also to deal with the similar kind of data set, Excel tabular format, Excel kind of data set. So, let us talk about this data structure. So, data frame. So, the name is also happens to be the same, and represents physically two dimensional data in a tabular format of rows and columns, and it is like a dict of series elements having a common row index. So, if if we can have a dict and all the there we have key value combination. So, all the values they can be series elements, and the keys that we have, if the keys are common. So, that is how we can consider this data frame. So, common key and multiple series elements. So, that kind of a dict we can consider data frame as that kind of dict object. So, data frame have both row and column index. So, in the series we have the explicit index, but only the row index. So, in this case in the data frame we will have the row and column index. So, we will have the indexing for the multiple columns that we will have, and also as usual we will have the indexing for the several rows that we are going to have in our data. So, row index is similar to series index that we have discussed, and default is going to be 0 to n minus 1, and of course, we can customize it as we have seen. Now, column index is nothing but variables name, because essentially these we are supposed to work with the heterogeneous data, different columns representing different variables. They could be of different, they could be having different data types. So, therefore, the column index is typically variables names, and by default they are sorted alphabetically. So, columns can be variables of different value types, as you can see, numeric, string, boolean, anything. So, these are so when we say numeric, string, boolean, this terminology is coming from the language perspective, that is the Python platform's perspective, that is different data type, different value types are defined one of these numeric, string, boolean. But from the analytics perspective we talk about categorical continuous variable. However, you can clearly see that, like we have discussed in our previous courses, how they can be easily mapped. Now, let us focus on the construction part of data frame. So, how a data frame object is created. So, created using a data frame function. So, let us take an example. We will take year wise metro population data for few metros in India. So, here we are defining a dict object, dict 1 here, and you can see the first key is metro, where we have a list of string values indicating the metro names, and repetition is also there because this is a year wise data. So, for different years and for these metros we will have the population in crores. So, hypothetical example here. So, you can see metro 6 values Delhi, Delhi, Delhi and Mumbai, 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 because in the second key value combination year we have data for 2011, 2012, 2013, and then you can see the repetition 2011, 2012 and 2013. So, from 2012 to 2011 to 2013 we will have data for these two metros Delhi and Mumbai, and you can see population in crores, few numbers we have given for this example. So, if I run this we will have this dict1 object, and then we can pass this dict1 object to create a data frame. So, we can call this function pd.dataframe and pass on this dict1 object, and then we will have our data frame. So, let me run this and let us have a look at the output. So, you can see output number 38, and you can see a table has been displayed there. So, you can see 3 columns are there, metro, year and pop CR, that is population in crores. So, in metro you can see first row Delhi, then Delhi, then Delhi, then next 3 rows Mumbai, 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 years 3 years 2011 then 12 and 13, and same for Mumbai, and population crores. And you can see the all this is 0 index. So, very first column explicit indexing column is there 0 1 2 3 4 5. So, this is the main structure of our data frame object. Now, as you would expect that we would be dealing with the larger data sets. So, therefore, it will run into several hundreds and thousands of rows. So, if you just have a look, if you just want to have a look at few values from the data set, we can use this particular method here df.head. So, it will just display first 5 rows of data. So, if I run this, you can see in this case we just have 6 rows of data. So, out of that first 5 rows are going to be displayed, as you can see in this output number 31. So, this is how we can actually work around data frame and series object. Now, we have lot more to discuss about data frame as well as series, and how we can apply different operations, do certain processing as per different analytic scenarios. So, we will continue our discussion in this lecture. We will stop here. Thank you.